All right, let's jump right into a genuine cosmic detective story. For years, we've been getting these strange, fleeting signals from the depths of space, incredibly powerful but gone in a flash. They're like a message without a sender, a cosmic crime scene without a culprit. Well, today, we're going to crack the case.
And this is the central question, right? For just a few thousandths of a second, something out there unleashes more energy than our sun puts out in days. And then, poof, it's gone. So you have to ask, what in the universe could possibly be powerful enough to do something like that?
These cosmic crimes have a name: fast radio bursts, or FRBs for short. They were first spotted way back in 2007, and they are the definition of transient. They pop up without any warning, and they vanish just as fast. So you can imagine figuring out where they come from has been a huge priority for astronomers everywhere. Now, every good investigation needs a person of interest, a prime suspect. And in this cosmic case, astronomers have had their eye on one of the most extreme, most violent objects in the entire universe for quite a while now. Meet the magnetar. Now, this thing is the super dense, hypermagnetized corpse of a giant star. Its magnetic field is so ridiculously powerful, it could literally wipe the data off your credit card from halfway to the moon. This is exactly the kind of extreme character you'd expect to be capable of producing an FRB. So, for a while, the investigation was pretty slow going. Just a few clues here and there. But then, the CHIME telescope came online, and suddenly the evidence started pouring in. But the real game changer, the moment detectives call their lucky break, came in 2020. For the very first time, we caught a suspect right in our own cosmic backyard. We actually saw an FRB come from a known magnetar, right here in the Milky Way. But just when we thought we had our culprit, the case took a turn. This signal from our local magnetar, it was just a tiny whisper compared to the colossal intergalactic shouts we've been hearing from other galaxies. So that raised a huge question. Are these two totally different things, or are we just seeing the same phenomenon from wildly different distances? To solve this puzzle, the investigators needed more than just a suspect at the scene. They needed a smoking gun. They had to prove somehow that the whisper in our galaxy and the shouts from across the universe were connected by the very same physics. And the key was to zoom out, to stop looking at individual bursts and start looking at the entire population. So scientists started comparing two key things: the sheer power of each burst and how often bursts of that particular power happen across the universe. You can kind of think of it like comparing how bright different light bulbs are to how many of them you'd find scattered across an entire city. And this, right here, this is the discovery. It's beautiful. The purple dots over on the left, those are the weak local magnetar bursts. The blue and green dots on the right, those are the super powerful distant FRBs. But when you plot them like this, they don't look like two different things at all, do they? They fall perfectly onto a single, continuous line. It's a direct mathematical relationship, a smoking gun. Now, here's what's truly mind-blowing about this. This single physical law holds true across 13 orders of magnitude of energy. 13. That is like having a single rule that explains both the gentle whisper of a mosquito's wings and the deafening roar of a rocket launch. The scale is just staggering, and it's the strongest proof we have that all these events are part of the same family. And the researchers themselves, they didn't mince words. They said this strong correlation is the evidence. It supports the idea that all of these bursts, whether they repeat or not, whether they're near or far, they all come from the same kind of object, magnetars. Okay, so we've got our smoking gun. It connects the weak, local bursts to the powerful, distant ones. The case for magnetars is looking really solid. But, a good detective knows the main suspect has to account for all the evidence, even the subtle, more complex fingerprints hidden inside the signal itself. And this is where something called polarization comes in. Just think of it like a unique fingerprint on the light wave. Most FRBs are what we call linearly polarized, meaning the light waves just wiggle back and forth in a straight line. But every now and then, we see some with circular polarization, where the waves actually spiral. So how can magnetars produce both? Well, a recent model came up with a really simple, elegant solution. The idea is that the FRB starts its life as a purely linear signal, but then it has to fight its way out of the magnetar's incredibly chaotic and magnetic environment. And as it travels through this super-energized plasma cloud, the journey itself actually twists the light, converting some of that linear fingerprint into a circular one. So here's the crucial part. This theory perfectly explains what we see. The model predicts that the conditions you need to create a lot of that circular polarization are really specific, and because of that, pretty rare. And that's exactly what the data shows us. Another piece of the puzzle just clicked into place. The suspect's fingerprints are matching up.
So at this point, the evidence seems pretty overwhelming, right? So is it case closed? Well, in science, the verdict is never quite that simple. And the process of how we reach a scientific consensus is a story all on its own.
Let's look at a real-world example. A few years ago, this absolutely incredible headline dropped, seemingly linking an FRB directly to a gravitational wave event. I mean, the ultimate smoking gun. It caused a huge stir.
But almost immediately, the scientific community on places like Reddit urged everyone to be cautious. An astronomer jumped into the conversation not to dismiss the finding, but to add some really important context.
And here's why. The gravitational wave detector could only narrow down the location to this huge patch of sky. We're talking about an area 100,000 times bigger than the full moon. And since our telescopes find new FRBs pretty much every single day, the odds of one just randomly popping up in that massive search area were actually pretty high. The link was probably just a coincidence. And this whole exchange is just a brilliant illustration of how science really works. As another user pointed out, peer review isn't some final stamp of absolute truth. It's more like a first step, a check to make sure the work is solid enough to be considered by other scientists. The real test is the long-term process of the entire community trying to replicate, verify, and build on those results.
So, after all that, where does that leave our investigation today? Have we finally convicted our prime suspect? The verdict is in. The evidence points squarely and overwhelmingly at Magnetars. Right now, they are the only suspect that can consistently explain the vast energy scale, how often these things happen, and those tricky fingerprint details within the signal itself. The case is solid. But in science, a case is never permanently closed. It's just waiting for new evidence. And that leaves us with one last really fascinating thought. We've tracked down the source of these incredible cosmic broadcasts. We found the universe's most powerful radio stations. So the next great mystery is, what else can we learn by tuning in and listening to what they have to say?